We've been talking about scatter plots. We know what those are. Today we're going to be talking about the curve of best fit. So as it turns out, it's not only lines that you can connect dots with. We just learned that you connect them with curves. We're going to use special words for each of these curves. It's pretty interesting stuff. If we have time, I'll show you guys something pretty interesting I think you might like. As you're going through this, I'll kind of go down. It's, in case you missed it, scatter plot curve of best fit is the name of the lesson. But in math, just want to show you that there's a lot of different types of curves. Here's a curve we won't be looking at today. You can just look at it. That is a cubic curve. It's a cubic function, meaning x to the third power. There are other curves, like this is a sine wave curve. It's still curvy. Won't be looking at that one. But the two that we will be looking at, the first one, this is called a parabola. Again, we'll spend another page on this, so you don't have to draw this right now. But basically, it's U-shaped. That kind of curve we will be looking at. And one of my personal favorites is the one we were just drawing, where it's kind of shallow at first, and then it goes up steep. That is an exponential curve. So for today, we're basically going to be focusing on these two curves. Again, the name of this lesson is Scatterplot's Curve of Best Fit. And on the worksheet, like I said, you only have three options. Linear, which we've just talked about, a straight line. And then we have the other two that we're going to mention. So first of all, the ones we've looked at so far mostly have linear relationships. Make sure you write this down. Linear just means that the curve of best fit is a straight line, and he just brought this up. Yes, it's still a straight line. It doesn't have to be, well, actually, if it is vertical, we know that that's undefined, right? But it doesn't matter how steep or how slight the line is. It's still considered a linear relationship. So, for example, if I had a line that was, say, this steep, well, that's not actually a line. Let's try that again. If I had a line that was that steep, that's linear, just as much as this line is. Doesn't matter how steep it is, and we know also it can be negative and it can go that way. So again, linear means the line of best fit is a straight line, and it could be steep or it could be a slight curve. Okay, the next one's one you're definitely going to have to write down. That word is quadratic relationship. Quadratic and the word parabola go hand in hand. A quadratic function has the shape of a parabola. Now, I wish we had time in this class to dive more into parabolas, and we actually will. We've only talked about lines so far, but this is a good segue because scatter plots can take on different shapes. We will talk about parabolas to a certain extent, meaning the vertex and stuff like that. But for now, what I want you to understand is it's a U-shape, and it can be either pointed up or pointed down. The second thing I want you to take note is it does change direction, meaning it goes from up to down or down to up. Lines do not change direction. A quadratic equation, you don't need to know it for this lesson, but it is a good point of reference. It just means that one of the x terms is being squared. This is just one of many examples. So that equation, if you were to graph it, would be one of those U-shapes. So when we look at these scatter plots, sometimes the curve of best fit is a U-shape, and we say that it has a quadratic relationship. And of course, it has an associated equation, which we could figure out too. We're not going to that much detail, but technically, you could draw the curve of best fit and then figure out what the equation for that is. Okay. And then the last relationship we're going to talk about today is exponential. Obviously, the line of best fit is an exponential curve. So it can either be shallow or steep. It can either start off shallow or end up steep, or vice versa. Let me give you an example of what that would look like, because there's actually four options. The first option looks like this. We already drew that one. See how it starts off shallow and goes steep? Now if you flip that horizontally, it starts off steep and gets shallow. That's still exponential. Okay, then it could actually go like this. So flipped vertically, And then, of course, the last way, whoops, I was about to do the same thing. The last way would be to go like that. So all four of those are exponential. We can see they all have the same shape. They just have a different orientation. So as long as it has a shallow and a steep part, and it doesn't change direction like a quadratic, it's going to be exponential. At least for the sake of this class, okay? We can get technical and talk about logarithms too, but logarithms are actually just another way of writing exponents, so they're still exponential curves actually. Now this is just a reminder, this is just a review, pretty much, but just take note that if it has no correlation, then there's obviously no curve of best fit. If there's a curve of best fit, there's obviously a correlation, but if there's no correlation, there's no way to connect those lines, those points with a curve. That's why somebody said a star, right? Because, yeah, you could technically connect any set of dots, but it's not going to make any sense.